Good day, everyone! I am Irma Jane Pagara. In this video, I will be answering 4 problems about the perpetuity. So let us start with the first problem. So find the present value of simple perpetuity of 1,000 pesos payable at the end of each quarter if money worth is 10% compounded quarterly. So the first thing we are doing is to find the given values. So we have our A, which is 1,000, M equals to 4, R is 10%, and I, which is R divided by M. So we have 10% divided by 4, and that is 2.5% or 0.025. So let's move to the solution. So our formula is P is equal to A over I. So our A is 1,000 and our I is 0.025. So 1,000 divided by 0.025 is 40,000. So our present value for the problem number 1 is 40,000. Now let's move to the second problem. So it says that find the present value of the simple ordinary annuity of 1,000 at 1% compounded quarterly payable at the end of every quarter for 50 years, for 60 years, and for 70 years. So we are solving 3 situations here for 50, 60, and 70 years. So first, let's look for the given values. So we have A, 1,000, R, 10%, M, 4, the T sub 1 is 50, or the first time is 50, the second time is 60, the third time is 70. And we also have our N, which is 200, N sub 1 is 200, N sub 2 is 240, N sub 3 is 280. So let's start with our solution for the 40 years. So our formula here is P is equal to A times 1 minus 1 plus I to the power of negative N over I. So we just going to substitute the values. So we have now 1,000 times 1 minus 1 plus 0.025 to the power of negative 200 over 0.025. So the answer of that is 39,713.39292. So that is the answer for the 50 years. So next is for the 60 years. So we also have the same formula, which is the P is equal to A times 1 minus 1 plus I to the power of negative N over I. So substitute the values. So we have 1,000 times 1 minus 1 plus 0.025 to the power of negative 240 over 0.025. So the final answer will be 39,893.25875. So that is for the 60 years. Now for the last one, we have 70 years. We will also use the same formula. P is equal to A times 1 minus 1 plus I to the power of negative N over I. So substitute the values. We have 1,000 times 1 minus 1 plus 0.025 to the power of negative 280 over 0.025. So the answer will be 39,960.24629. So that answer will be for 70 years. Now let's move to the third problem. We have find the present value of perpetuity due of 2,000 pesos payable at the beginning of each quarter if money is worth 10,000 compounded quarterly. So first, let's look for the given values. So we have our A, 2,000, R, 10%, M is 4, and our I, to solve for I, we have R divided by M. So we have 10,000 divided by 4, and that is 0.025. So the solution will be like this. The formula, we have P is equal to AI plus A. So, substitute the values. We have 2,000 divided by 0.025 plus 2,000. And the answer will be 82,200. So, 82,200 is our present value for the third problem. Now, let's move to the last problem, the fourth one. So, it states that find the present value of the annuity due of 2,000 payable at 10% compounded quarterly, payable at the beginning of each quarter for 50 years, for 60 years, and for 70 years. Once again, we are going to solve for 3 situations in just one problem. So first, we are going to look for the present values. So we have our A, 2,000, R, which is 10%, M, 4, and our I, 10,000 divided by 4, that is 0.025. Our time 1 to 3, time 1, 50, time 2, 60, time 3, 70. And we also have our N sub 1, 200, N sub 2, 240, and N sub 3, 280. So let's solve first for the 50 years. So we have the formula P is equal to A times 1 minus 1 plus I to the power of negative N over I times 1 plus I. So substitute the values. We have 2,000 times 1 minus 1 plus 0.025 to the power of negative 200 over 0.025 times 1 plus 0.025. And the answer will be 81,412.45549. That is for the 50 years. For in 60 years, we are going to use the same formula, which is P is equal to 8 times 1 minus 1 plus I to the power of negative N over I times 1 plus I. So substitute the values. We have 2,000 times 1 minus 1 plus 0.025 to the power of negative 240 over 0.025 times 1 plus 0.025. And the final answer will be 81,781.18043. That is for the 60 years. And last one, we have for the 70 years, we are going to use the same formula. P is equal to A times 1 minus 1 plus I to the power of negative 280 over I times 1 plus I. So substitute again the values. We have 2,000 times 1 minus 1 plus 0.025 to the power of negative 280 over 0.025 times 1 plus 0.025. And the final answer will be 81,980.50489. And that is for the 70 years. So I answered all the 4 problems. So thank you and may God bless us all.